Let's take a look at this review problem factoring this quartic polynomial x to the fourth minus 5x cubed plus 15 halves x squared minus 2x minus 2. We will proceed by using the rational root test. However, before we do that, notice that there is a coefficient here that's not an integer. And so I can't use the rational root test yet because of this term here that's not an integer. What I need to do first is factor out that half. So 2x to the fourth minus 10x to the third plus 15x squared minus 4x minus 4. I can then apply the rational root test on this new thing inside the parentheses. So the possible rational roots things that go into the constant term are going to be, the factors of the constant term are 1, 2, and 4. And the factors of the leading coefficient are 1 and 2. And so this gives me a list of candidates to test, and there are 8 candidates that could be rational roots of this polynomial. Again, there's no promise that any of these will work, and certainly not all 8 of these will work. To narrow down the list, we want to show the graph of this polynomial. So if you look at the graph of the polynomial, it looks like there's a root here, but that's not negative a half. 1 is not a root. There's a root here that's not 1. But it looks promising that 2 might be a root, and because it's touching the axis, it might well be a double root. So let's try 2 on the factored part here. So 2, negative 10, 15, negative 4, negative 4. And let's see if 2 actually works. It certainly looked promising from the picture. So 2 times 2 is 4. Negative 2 plus 4 is negative 6. Negative 6 times 2 is negative 12. 15 plus negative 12 is 3. 3 times 2 is 6. 6 plus negative 4 is 2. 2 times 2 is 4. 4 plus negative 4 is 0. So 2 works, and we're hoping that 2 works a second time. So 2 times 2 is 4. Negative 6 times negative 6 plus 4 is negative 2. Negative 2 times negative 2 is negative 4. 3 plus negative 4 is negative 1. Negative 4 times 2 is negative 2. And lo and behold, it works a second time. So while we could have plugged in 2 into this equation to see that it was a root, we have to use synthetic division to see if it's a double root. So our conclusion is that f of x is equal to 1/2 x minus 2 squared times 2x squared minus 2x minus 1. And let me pull the 2 out of this. So that would give us x minus 2 squared times x squared minus a x minus a half. Okay, now to find the remaining roots, I use the quadratic formula to see what the remaining roots would be. So I'll do that over here on the side. X is equal to 1 plus or minus square root of 1 minus 4ac all over 2. So 1 plus or minus square root of 3 over 2. So I have 2 real roots. And so this actually factors, because the problem asks us to factor it over the real numbers. We don't ordinarily factor like this, but this would be the factorization over all real numbers. X minus 1 plus I squared of 1 plus square root of 3 over 2. Then x minus 1 minus square root of 3 over 2. And so the roots would be 2, that's a double root, and 1 plus square root of 3 over 2, and 1 minus square root of 3 over 2. And looking back at the graph, we see that this root here corresponds to 1 plus square root of 3 over 2. This root over here corresponds, or this intercept over here corresponds to 1 minus square root of 3 over 2.